In this video, let us solve problems based on the signs of the trigonometric ratios. We did see in the previous video what the signs of the trigonometric ratios are in the various quadrants that there is. So here, let us put that to practice. Let's kind of apply that concept here. So here we've got the problem. The problem reads like this. It says find sine theta and tan theta if cos theta equals negative of 12 by 13 and theta lies in the third quadrant. Alright, so what we have to do is, we've got the value of cosine theta, that is the cos theta, as negative 12 by 13, and they also say that theta lies in the third quadrant. A quick recap here. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So the theta lies in the third quadrant here, right? ASTC, so this is T. So tan and cot are positive here. Nothing else is positive, right? Tan and cot are positive here. Everything else are negative here. So that's one thing that you have to remember before you solve this problem. So that's one thing that we've got it right. And then what we have to do is, first we have to find sine square theta. Now since the theta lies in the third quadrant, sine theta is going to be negative. And well, how are we going to do that? We're going to use one of the identities here. So we've got sine square theta plus cos square theta equals 1. The reason I'm taking this identity is we've got the cos theta value and we've got 1 and we have to find sine theta, right? So that's why. So sine square theta will be equal to 1 minus cos square theta, but we do not want sine square theta, right? We just need sine theta. So sine theta will be equal to square root, positive or negative, of 1 minus cos square theta. You know that always before a square root, the signs are 2. You can get two values, positive or negative. But in this case, since the theta lies in the third quadrant, the value of sine theta will be negative. So therefore, sine theta will be equal to minus of square root of 1 minus cos square theta. Right? So now let's substitute the value of cos theta in this. We get sine theta equals negative of root of 1 minus of 12 by 13 the whole square. Right? Now if you solve this, you're going to get minus 5 by 13. Well, if you solve this inside, you're going to get 5 by 13. And the negative sign from outside the square root is going to be accompanying this. So we found the value of sine theta, right? So sine theta equals minus 5 by 13. And I hope by now you know why it is negative 5 by 13, because the theta lies in the third quadrant and the sign of theta in the third quadrant is a negative. So that's that. Now let us come to tan theta. So coming to tan theta, what is it going to be? It's going to be positive, right? Because it's in the third quadrant, and third quadrant tan and cot are positive. So tan theta is nothing but sine theta by cos theta. Now why so simple here? Because we know the values of cos theta also and sine theta also. So all you have to do is sine theta is minus 5 by 13 and divided by cos theta is minus 12 by 13. You know that fraction by fraction is nothing but the numerator multiplied by the reciprocal of the denominator. So minus 5 by 13 times minus 13 by 12. The negative gets cancelled, or negative when multiplied becomes plus. 13 gets cancelled, and you get tan theta is equal to 5 by 12. So this is how you use the signs of the trigonometric ratios while solving problems. Well, it's not just this. There are lots of different kind of problems that we're going to solve which will need you using the signs of trigonometric ratios. But as for this problem is concerned, it's done. So I'll see you in the forthcoming videos with more problems based on the signs of trigonometric ratios.